The limit process is involving describing the behavior of the function f of x, which is just y, as the input value, x, approaches some number c. Now, if I were to look at this function, which is f of x equals 2x squared plus 3x minus 3, it says determine the behavior of the function, that's y, as x approaches 1. If I take a look at my table, this is a table of values, and I notice that this is x, this is y, and I notice that x is getting closer and closer to 1 from the left, and here x is getting closer and closer and closer to 1 from the right. But what happens to y? As x moves closer to 1, I notice y here is 1.32, 1.932, 1.993. Each time now I add a 9, I'm getting a 9 in front of another 9 behind the 1. So it's pushing it and pushing it till I have 1 and a bunch of 0.9s. That's very close to the number 2. If I were to round 1.9, that would round to 2. 1.99 would round to 2. 1.999 would round to 2. Now, if I come the other direction, I look at 1.1 is 2.72, 1.01, 2.0702, 1.001, now it's added another 0 behind the 2. I add another 0 on the behind the 1 on the x, and adds another 0 behind the 2 on the y, and it says you look at it, if I round this to the nearest integer, it's 2, and round this to the nearest tenth, it's 2, round it to the nearest hundredth, it's still 2. It's getting closer and closer to 2. So as x approaches one, and that is from the left and from the right, y responds and approaches the number 2. And that's happening on the same, on this side. Y responds and approaches 2. So y is only responding to x. So if this is the graph of 2x squared here is the coordinate point 1, 2. As x goes to 1, you notice that on the graph, y is approaching that coordinate point. Y goes to 2. So as x approaches 1, y goes to the coordinate point of 1, 2, or y goes to 2. Now what if I have something which looks like that, and now I'm still going to approach 1. Now we remember that if I were to put in x equal 1, I get 0 over 0. 0 over 0 is meaningless. I usually say, I don't know. I mean, I haven't a clue if I get 0 over 0. It's called an indeterminate form. So that's what it's called. Now, if I look at the same chart, here I notice that x is approaching 1. And from the left and from the right. But what's y doing? Well, I notice that as I'm coming in, it looks like if I'm not here, it looks like I'm going to 2. If I come in from the other side, it also looks like I'm probably going to end up at 2. If I'm at 1, there's an error because I have a 0 divided by 0. But if I look like, it looks like, before I get to x equal 1, it looks like y is going to 2 from both sides. If I don't look at what's happening there, it looks like y goes to 2. Except at x equal 1. Why it's an error. Now, why is that? Well, if I take a look at what's happening at x equal 1, this is a picture of the graph, there is a hole in the graph. So, x equal 1, y does not exist. Y doesn't exist because I have a hole in the graph. But if I were to, again, as x approaches 1, I notice that y is headed toward a y value of 2. It just doesn't get there. But if I take a look at the table, it sure looks like I can get pretty close. And I say, it looks like it's going to be 2.